I'm going to cover balancing chemical equations, and in this topic I'm going to look at balancing chemical equations and the mechanism involved for good balancing. Now, before we proceed, this is exactly what student must know. Now, the first thing is about variance of various elements and various radicals. We have elements and radicals. Now, let us see some of the variances of various elements. Now, variances are very important for a student to know. Now, let's see variance one element and radicals. Variance one element and radicals. So elements, we have sodium with variance 1, we have potassium with variance 1, we have silver with variance 1, we have chlorine, this is a chloride ion, with valence 1. Now radicals, we have ammonium, this is ammonium ion, we have nitrate, this is with 1, we have hydrogen carbonate with 1, we also have hydrogen sulfate with 1. All these are some examples of those elements and radicals with valence 1. Now, we can go to valence 2 elements and radicals. Remember, radicals are group of elements carrying the same charge. Now, we have calcium, we have magnesium, we have barium, we have copper, we have iron, we have iron 2, we have sulfate ion, we have sulfite ion, we have carbonate, and also we have lead. All these are valence 2 elements and also the radicals. Valence 3, we can look at a few. Valence 3, we have aluminium 3, we have iron 3, we also have nitrogen with 3, and we can just give those as the examples. Now, remember the formulas. After valence, we need to know how to write formulas. For example, a formula of magnesium nitride. A formula between magnesium and nitrogen. So magnesium nitride is written as, we have 2 of magnesium comes here, we have 3 of nitrogen at the bottom. So magnesium nitride is written as that one is a solid. That is how magnesium nitride is written. Another one, we can look at probably something like aluminium. Uh, let us look at magnesium carbonate. Magnesium carbonate is just MgCO3. 2 will cancel, so we have something of that nature. Here we can look at probably sodium carbonate. Sodium carbonate, sodium is 1, carbonate 2, so 2 there, and carbonate. So that is how to write some formula now using that knowledge of variance. Now, the next thing that we need to look at is what we call the reactions. We can look at reactions. Now, we know that metal plus acid, we normally get salt and hydrogen gas. Remember, we also have metal carbonate plus acid. We normally get salt, carbon dioxide, and water. Something else are acid plus base, or acid plus metal oxide, acid plus metal hydroxide. All these are known as neutralization reaction, which normally gives us salt and water. Now, something else that we need to look at is the solubility of some salts. Now, we know that all nitrates are soluble. No question there. No question there. Number 2, all carbonates are insoluble, except we have sodium carbonate, potassium carbonate, and ammonium carbonate. Only those. The next one, we can look at sulfate. All sulfates are soluble, except barium, calcium, and lead sulfate salts. The other one, we can look at sulfite. All sulfites are soluble, except barium sulfite, calcium sulfite, and lead 2 sulfite. Next, we can look at chloride. All chlorides are soluble, except 2. That is silver chloride and lead 2 chloride. Next, we can say that all sodium, potassium, and ammonium salts are soluble. We can also say that all hydrogen sulfates and all hydrogen carbonate salts are soluble. Now, having looked at all these, we can now proceed and see how we can tackle these questions on balancing chemical equation. Now, why is this important? Remember, in balancing equation, we need to give the state symbols. For the salts that are insoluble, that means they are solid. So we have to make sure that we assign a symbol S under them. Now, these are our questions, complete and balanced. Now, question number 1, we have magnesium plus sulfuric acid. We have magnesium sulfate aqueous plus hydrogen gas. So therefore, magnesium plus sulfuric acid is magnesium sulfate, then plus hydrogen gas. Is it balanced? It is balanced. Now, let us proceed. Number 2, we have silver nitrate plus magnesium chloride. So what we get, this one is magnesium nitrate to there plus silver chloride. Now, the question is here, the state symbols. All nitrates are soluble, so we have aqueous here. All chloride are soluble apart from that of silver, so therefore this is a solid. Now, so we have to make sure that we give a good state symbol there, S. We have to assign the correct state symbols. Now, is our equation balanced? Look at silver one here, silver one. We can look at this is 2, remember this is 2. We can look at nitrate or nitrogen. Nitrogen here is 1, here we have 2, so put 2 there. Putting 2 there introduces silver as 2, so we need to put 2 there. Remember, chloride are 2 here, so there are 2 here. The equation is well balanced. Question number 3, we have zinc carbonate plus nitric acid. Remember, metal carbonate plus an acid is normally carbon dioxide, salt, and water. So therefore, we will get zinc nitrate plus carbon dioxide plus water, liquid. This is aqueous. Now, is everything balanced here? Look at it well and balance where necessary. So we need to put 2 there, and everything else here is balanced. 2 hydrogen, everything here is balanced. Now, proceed to the next part. Part 4, we have lead nitrate plus potassium sulfate. What do we get? This one will be lead sulfate plus potassium nitrate. Now, all nitrates are soluble, so aqueous. All sulfates are soluble apart from that one of lead, calcium, and barium sulfate. So this is a solid. Now, is our equation here balanced? Look at it well. 2 potassium, 1. So we need 2 there. 2, 2. So our equation is well balanced. Number 5, this one is a neutralization reaction, a base plus an acid, so salt and water. So therefore the salt will be sodium chloride, this is aqueous, plus water, this is liquid. Is it balanced? Yes. 1 sodium, 1 sodium. Oxygen is 1 1. Hydrogen are 2 1 2. They are 2. Chlorine 1 1. So it's well balanced. Finally, number 6, we have copper 2 sulfate plus sodium carbonate. What do we get? So we have copper carbonate plus sodium sulfate. This is okay, we said that all sulfates are soluble apart from the one that we saw, but all salts of sodium, potassium and ammonium are soluble. So this is aqueous. All carbonates are insoluble apart from that of group 1 element and ammonium. So this is solid. Balanced, look at it. Where do we need to put what? So everything is balanced. Now, in balancing equation or in lighting all this, so you have to pay attention on 3 things. We have seen number 1 is variance. Number 2 is the reaction. When we react metal and acid, what do we get? So reaction, you have to make sure that you understand when an acid reacts with a metal carbonate, what are the products? When you have 2 reactants, when they react to give what? So you must be able to tell all that. The other thing is about solubility. Solubility, some salts are insoluble. So the state symbol are normally solid for those salts that are insoluble. Them that are soluble, then that means that the state symbol will be aqueous. All they are in solution